Hello, 7th graders. Today we're going to talk about solving inequalities when dealing with word problems. Alright, so for each of the following examples, we're going to write and solve the inequality described in each of the following situations. So for number 1, it says that Sam has at most, there's our inequality, $27 to order pizza. The place he ordered the pizza from charges a $3 delivery fee, so that's a one-time fee, and each pizza costs $6. And that was each for every single pizza. So how many pizzas can Sam order? The first step is writing our let statement or defining our variable. So we are going to let x equal the number of pizzas Sam can order. The next step is to write our inequality. So once again, going back to the beginning here, it says that he can order he has at most $27. Well, at most means less than or equal to $27. He can spend $27 or less. The place he ordered the pizza from charges a $3 delivery fee. Well, since that's just a one-time fee, we're just going to put 3 plus the cost of each pizza, which would be 6x. Next step is we just go ahead and solve it. So if I want to, the first inverse operation would be subtracting 3 from both sides, and I'm left with 6x on the left is less than or equal to 24. And the final step is divide by 6 on both sides, and I get x is less than or equal to 4. Now I don't have to flip the sign because we divided by a positive. So in the end, the maximum amount of pizzas that he can order is 4. He can order 4 or less pizzas. X is less than or equal to 4. Number 2 says Charles is saving $5 each week and earns an extra $15 just one time by mowing his neighbor's lawn. How many weeks will he need to save in order to have at least, there's our inequality, $75? So we're going to let x equal the number of weeks that's going to take him. Our inequality, when we're writing this out, let's first write out showing that we have at least. Well, at least means $75 or more, so greater than or equal to 75. And on the left side, it says that he's saving $5 each week. Well, that's 5x. And then on top of that, the one-time $15. So when we go to solve that, the first step is for us to subtract out that 15 from both sides. On the left, those cancel, leaving me with 5x. And on the right, I have 75 minus 15, which is 60. Final step is to divide both sides by 5, and we finally have x alone. I'm left with x is greater than or equal to 12. So what that means is he has to save for at least 12 weeks. He has to save for 12 or more weeks in order to save at least $75. So for our final problem, it says Alyssa won 40 lollipops playing basketball at the school fair. She gave 2 to every student in her class, so 2 each, and now has a minimum, there's our inequality, of 7 lollipops left. How many students are in her class? So we're going to let x equal the number of students in Alyssa's class. And when we're writing out our inequality, we need to look back and think, okay, minimum means that she has to have 7 or more, so greater than or equal to 7. On the left side, she started with 40, but she gave 2 to every student away. She's subtracting out 2x, 2 each. And then when we go to solve this, the first step is to subtract 40 from both sides. On the left, we're left with our negative 2x. We can't forget about that sign that's in front. It's like plus a negative. And we have greater than or equal to negative 33. Last step, divide by negative 2, divide by negative 2, and we're left with x on the left side. And since we divided by a negative, instead of having greater than or equal to, it has to switch to less than or equal to. A negative divided by a negative is a positive, so I'm left with 16.5. Well, I can't have half a person, and since x has to be less than or equal to 16.5, I can't round up. I have to round down to x is less than or equal to 16. So she has 16 or less people in her class.